All right, so today we are going to talk about containers. So before we understand what containers are, we need to understand the problem that they solve. Because in real engineering, we don't start with tools, like we start with the problems first. So first, let's build some context. Okay, let me take some example. Let's take any example of real world application. Maybe you can take example of Uber, Netflix, Ola, Hotstar, whatever. But how the things start? Basically, someone like a developer, right, or the dev team, you can say, the dev guy, who is going to write a piece of code, right? This guy will write a code, okay, and you can say code, and we can also say uh, it's basically kind of an application. This is the app, okay, somewhere. This is what the whole story. This app must be running somewhere. Okay, when I'm saying running means like people will, the end user must utilize this particular application. If you talk about any application, at the end of the day, it is just a code written by the developer, and the goal is this particular code should run somewhere, right? So the first question is, what are the, where do we run this application, where we can go and run this particular application? So there are multiple options. Let's try to explore one option at a time. So first option that is available is like a server, any physical server, or physical bare metal server. Okay, this is a server where we can go and run this particular server. This server will have something known as hardware. Okay, when I'm saying hardware, it's basically kind of a CPU, RAM. Okay, it have disk, network, like all these comes under the hardware. The hardware is right now is for us is RAM and CPU. Okay, the hardware for us right now is RAM and CPU. This, on top of this hardware, will have something known as operating system. Okay, we'll have something known as operating system. And on top of this operating system, my application will be running something like this. All right. So just an hypothetical situation. Let's assume that we have 10 GB of a RAM. Okay, and we have 10 CPUs. All right, we have 10 GB of a RAM and 10 CPUs. And let's say my application consume 2 GB of a RAM and 2 CPU. And in order to keep the thing simple, let's say operating system will also consume 2 GB of a RAM and 2 CPU. All right. What is this architecture? What do you think? Is this a good design, bad design? What do you think? Is there anything wrong? There is nothing wrong in this, right? I mean, this is not a wrong architecture or wrong design, but if you think about at scale, this will become very expensive. If you are running your application in order to maintain the high availability and a lot of other system design concept, this particular architecture will become very expensive, because you are kind of you are paying for the infrastructure and that you are not fully utilizing it. This is the main concern here. We are paying for 100%, okay, and we are just utilizing almost 40% of the hardware. So this particular architecture, there's no problem, but at scale, this architecture will be super expensive. Okay, so what we can do for this? Like, I mean, this architecture will become super expensive at scale. So why not we can run multiple application on the same server? The idea is not bad. Let's try it. So let's copy this architecture diagram and paste it here. Instead of running one application now, we will be running multiple application. Let's say I am running one more application. Let's say run one more application. So now we are running almost right now, we are running multiple application. We have, let's say this is my app. Okay, app underscore A running app underscore B running app underscore C is running. All my applications are running. So we have app A, app B, app C running. Now what is your resource utilization? Resource utilization is like, let's assume that all the application will consume 2 GB of a RAM and 2 CPUs. So it's almost 80% we are utilized. We are almost 80% utilized. So the resource utilization improve. This is better from a cost perspective, right? I mean, this architecture is no doubt, this particular architecture from here to here. Okay. This is a better with respect to cost. Okay, I can say this is a better architecture with respect to cost or cost perspective. Okay. Now, is there any problem in this architecture? Is there any problem that you can see or sense? I can see a couple of problems. First of all, let's talk about the problems. Okay. So the problem number one is like lack of isolation. What do you mean by that, lack of isolation? So let me first write it down. Lack of isolation. All the application running on the same operating system, right? When I'm saying same operating system, like, this application is using the same operating system, this application using the same operating system, this application using the same operating system, right? All the applications are running the same operating system. This means that they are using the same kernel. Lack of isolation, I can say same operating system. I can further say, like, same kernel. Okay. Same kernel. I can say that they share the same process space, right? They share the same process space. That is, again, it's there, right? And they share the same file system to some extent, isn't it, right? They are sharing the same file system to some extent. So this is one of the problem, right? If one application is misconfigured or compromised, it can potentially impact the other application, because there is the applications are not strongly isolated. Okay. The second problem in this particular architecture I can see is resource capping. Okay. Resource contention. Let's say application A, okay. Let's say this particular application A start getting huge traffic. This particular application is kind of a live streaming something like IPL or something, and they start getting huge traffic. So what this application will do? This application will consume more amount of CPU and more amount of memory. Yeah, obviously this will consume more CPU, more memory. And what is going to happen with the application B and C? And they may become unstable, right? That is another challenge. Yes, that could be another challenge, because there is no strict control by default, like which application will get how much amount of CPU, RAM, and so on and so forth. This is another problem that I can see, right? What is another problem? What is there any other problem? There are few other problem I can say. The problem of the dependency conflict. There may be chances of dependency conflict. What do you mean by that? Let's say my application A has written in Node.js, let's say 18, okay, and application B written in Node 16. Can they run both 18 and 16 can run on the same OS without any issue? May or may not be, but the higher chances maybe they may have some kind of a difficulty. So you will start getting version issues, libraries, config issues, okay, and this become your application deployment becomes very messy, okay, and it's very difficult to kind of manage these kind of a dependency or solve this kind of a dependency problem, right? And what else could be an issue? I would say there could be one more issue. Okay, so I can say, let's say the application is working on my machine. Somehow I manage everything. Okay, works on my machine, but the biggest issue could be the developers say it works on my machine, but on the other server, like where the operating system is little different, we have some different libraries, missing dependencies, application may fail. It's not portable, right? It is running here that we have somehow resolved all the issues. All these applications are running on the, you can say, on this particular hardware. But when we migrate this application or may ship this application because of any reason, then in that scenario, what will happen? Probably it won't run, right? So application may fail. So, but application is failing not because of the coding issue. Okay, application fails on different machine, but it is not failing because of the coding issue. It may be an environment issue. So now we have a clear picture, right? Running multiple application on a single server, no doubt we are getting a better utilization of CPU and RAM. So it is basically giving, like, better utilization, no doubt it's there. But it also introduced a lot of other problems, like, isolation problem, dependency conflict, environmental inconsistency issues, okay, resource fight, right? So how you are going to solve this problem, right? So that is what, like, I something we need to understand. This is what happens few years, I would say a decade or 15 year, almost 20 years back somewhere. Okay, so this problem, like, people started try to solve it, and the way they have solved it, okay, the way they have solved it, that particular thing we called virtual machine. Okay, there's a concept of virtual machine. With the help of virtual machine, we will see how we can solve this kind of problem. But you understand, right? I mean, the whole idea is here to run this particular application. This app must be running. Okay, fine, we want to run this particular application. What are the ways to run this application? The first option was, like, I can say this is the option number 1, to run on a physical machine, on a server, right? Okay, fine, we can run our application on a server, but this could be a very expensive design if you're just running one application on one server, right? So that is going to be cost a lot of money. So that way, like, we will see how we can solve this problem in VM, and this is what the next section we are going to discuss. So I will tell you in the next section, like, how VMs has been designed, how VMs run the application so that we can solve all these problems, and running the application on a VM, what kind of other challenges that we may face. So I'll stop here. Let's meet in the next video. Thank you very much.